On a misty February day in the Netherlands, Turkish 1951 is approaching one of Europe's busiest airports, Amsterdam Schiphol. The crew had almost completed its flight from Istanbul when it crashed just a mile short of the runway without transmitting a distress call. What happened here? Find out with me today as we take a look at Turkish Airlines Flight 1951. Subscribe so you won't miss any future episodes. Welcome to Airspace. On February 25, 2009, the crew of a Turkish Airlines Boeing 737 found themselves over Germany. They had almost completed their flight from Istanbul to Amsterdam, and it was time to prepare for the approach that they were about to begin. On the flight deck, there were 3 pilots that day: an instructor captain in the left seat, a first officer in training in the right seat, and a more experienced first officer seated behind him, filling the role of a safety pilot. The first officer in training was by no means inexperienced. He had already accumulated over 4,000 flying hours in the Turkish Air Force and now wanted to switch to flying commercial passenger jets. Flight 1951 marked his 17th flight on the Boeing 737, and he had performed well up to that day. Today would mark the first time he would fly an approach in Amsterdam. The weather was quite normal European winter weather, with a visibility of about 2,500 to 3,500 meters, that's roughly 1.5 to 2 miles. Other than that, there were no difficulties for the approach. As the 737 approached the airport, they received vectors, that means air traffic control provided them with all instructions as to what height, direction and what speed to fly. The aircraft was brought to an altitude of 2,000 feet above the ground, where the air traffic controller issued directions to the crew to provide a good intercept of the final approach track and glide slope. However, due to the short nature of the approach path that the air traffic control provided and due to the prevailing wind, the aircraft was slightly above the glide slope when it reached the horizontal approach path. This increased the crew's workload somewhat, since they now had to simultaneously descend the plane quickly, reduce speed, deploy the landing gear and flaps, and perform the landing checklist, all in a pretty short span of time. As the aircraft descended towards the runway, the safety pilot remarked that he had noticed an odd indication. The captain's radio altimeter showed a height of -8 feet. The radio altimeter is a device installed on the belly of the plane that bounces radio waves off the ground below and uses the time the signal needs to return to the aircraft to measure the distance above the ground. It's sort of like an oversized parking sensor on your car. The measured height is then displayed on the pilot's display to provide an indication on how far away the ground is. The indication they now received, -8 feet, made no sense, since that would mean that the aircraft is below the ground. The captain acknowledged it, but made no further comment on it. The crew continued their approach. Soon, the aircraft successfully descended to the correct glide slope from above, and the autopilot captured and followed it. Now, the pilots were ready for the landing. But they missed one crucial detail. Their airspeed had started to drop gradually below their intended approach speed of 144 knots. To compensate for the lack of airspeed and lift, the plane's autopilot started to raise the nose more and more to provide the much-needed lift. When the airspeed reached 107 knots, 37 knots below the targeted approach speed, the plane's stick shaker activated. This device rattles the control column to warn the pilots that the plane is about to stall and lose most of its lift. The first officer reacted promptly and advanced the thrust levers about halfway forward and started lowering the nose to help the plane regain some much-needed speed. But almost immediately, the captain took control by announcing that he would fly the aircraft. As the first officer removed his hands from the throttles, they once again returned to the idle position. Now, the captain lowered the nose, but took almost 7 seconds to advance the thrust levers to full power. In the meantime, the airspeed had dropped to below 100 knots and the plane was in a stall. Seconds later, it crashed into a field a mile short of runway 18 right. It hit the ground tail first and broke up into 3 sections. The engines separated. Immediately after the crash, an evacuation was initiated. Of the 135 occupants, 9 died, including the pilots. Almost everyone on board received injuries, most of them spinal injuries due to the almost vertical impact. The investigation began not even an hour after the crash of the airliner. The flight data recorder and the cockpit voice recorder were secured and read out successfully. What immediately puzzled the investigators was the fact that the radio altimeter that had shown the erroneous readings had apparently been faulty since the departure in Istanbul. During the flight, its failure had no consequences, but first signs of something being amiss presented themselves while the 737 was entering Dutch airspace. Over a period of 7 minutes, the landing gear not down warning came on 4 times. This warning is intended to warn pilots that they have forgotten to lower the landing gear when shortly before landing. Since the radio altimeter measured a very low height, the associated systems believed that the aircraft was in fact close to the ground and the landing gear was not down. At this time, the aircraft was still at an altitude of over 8,000 feet, so it was perfectly fine that the landing gear was not lowered. This is usually done at around 2,000 feet. The crew did not comment on these warnings, with one exception. At one time, the captain said "landing gear" and the first officer acknowledged with "okay." Air traffic control guided the plane to the instrument landing system of runway 18 right. However, the lineup was a bit too short, bringing the plane on the horizontal part of the instrument landing system, the localizer, a bit later than normal. Usually, planes are brought to the approach path in a manner that allows them to intercept the horizontal localizer first, then the glide slope from below. This creates a lot less workload than when one has to intercept from above. In the case of Turkish 1951, the controller meant a little too well and brought the crew onto the localizer after the beginning of the glide slope. Since one may not descend on the glide slope before being established on the localizer, the crew now had to intercept said glide slope from above. It was here that the investigators discovered a key element that led to this accident. As soon as the plane was established on the localizer, the first officer set a descent rate on the autopilot control panel so that the plane may descend to capture the glide slope. The plane needed to descend quite steeply, and the airspeed was still quite high, so it was expected that in order to descend, the engines would reduce their thrust to idle in order to not produce any excess energy in the form of speed that later would have to be reduced again before landing. Normally, this would be indicated to the pilots in the top left corner of the primary flight displays. Here, the state of the automatic thrust control system is shown. During a regular approach, it would say MCP speed, referring to the fact that the engines responded to the speed the pilot entered in the flight control system. If this entered speed was way lower than the actual speed, as it was the case for this accident, the engines would roll back to idle to allow the speed to come back to the selected value. However, the pilots of Turkish 1951 never got this indication. Instead, the mode retard came on. No, that's not a bad word. Retard is simply a technical term for reduced thrust levers. However, this mode was uncalled for at this altitude. Normally, it comes on below 27 feet when coming into land, to reduce the thrust levers to idle before touchdown. In the end, this mode had the same effect as MCP speed. It reduced the engine thrust to idle. But why did this retard mode engage when still high up in the air? Remember that the captain's radio altimeter showed -8 feet the entire time? Due to this, the plane's computers believed that the approach was over as soon as the plane captured the first part of the instrument landing system. To simplify, its logic must have been, "Hey, I have a landing system signal and I'm very close to the ground, so I have to reduce the thrust since my pilots surely must be landing right now." However, this was not the case. This flawed logic had provided no immediate problems. The plane was high and fast and descended at almost constant speed until it captured the glide slope. When it did, the dire situation developed. As the plane glided down the 3-degree slope, it gradually started losing speed since the engines were now still in idle. But when the speed reached the intended 144 knots, nothing happened. Normally, the engines would now spin up and maintain the selected speed, but since the plane's computers figured that they were already in the landing maneuver, the engines stayed at idle. The airspeed decayed more and more, but none of the pilots noticed that. At that time, they were busy with a late landing checklist. In fact, they even violated their own company procedures, which dictate that all actions must be completed by 1,000 feet above the ground, which would have compelled them to go around and try again. But this crew, as so many others before them, ignored this rule. But it is beyond me how they could have missed their decaying speed and the fact that their plane pitched up to an attitude that is similar to an attitude experienced during takeoff. When the speed reached a critical value of about 107 knots, the stick shaker activated and the first officer reacted promptly by beginning to advance the thrust levers. However, when the captain announced that he would now fly the plane, the first officer let go and the auto thrust once again reduced the engines to idle power, since it believed the plane was close to the ground. The captain reacted with pitch inputs, but did not re-advance the thrust levers immediately. He waited almost 7 seconds to do that, but after that time, it was too late. The airspeed had dropped to below 100 knots and the plane had stalled and was now falling rapidly to the ground below. Simulator tests showed that the recovery was impossible after the plane stalled. About 800 feet of altitude would have been necessary to recover, but the plane was at only 500 feet at this time. However, the board also noted that a recovery would have been very much possible to do at the time that the first officer advanced the thrust levers. Had his actions been complete and decisive, the situation could have been avoided. The Dutch safety board also took a closer look at the reason why the radio altimeter failed. However, it could not be determined. But the board discovered that Turkish Airlines had reported 235 radio altimeter issues in only 13 months. 16 of these concerned the accident aircraft. This raised questions about the reliability of the system, and the board urged Boeing to improve the system. Also, the final report made several remarks about crew resource management and crew performance at Turkish Airlines. The investigators found it concerning that no pilot really mentioned the landing gear warning, no pilot reacted to the radio altimeter failure when it was discovered, and no pilot called out the flight mode annunciators on the primary flight display. This is a tedious but mandatory task that pilots have to do in order to always know what their flight computers are doing. I know from experience that it is somewhat annoying. Imagine that you had to call out text message notification or YouTube upload notification every time that your phone buzzed. Nevertheless, it is mandatory and it must not be omitted. And finally, the Dutch investigators noted that while it was common practice for air traffic controllers at Amsterdam to provide rather short approaches with localizer lineups that do not match the glide slope, this goes against internationally defined standards and should not be done without first consulting the pilots. Thank you very much for watching. I hope you liked this week's video. Make sure to subscribe so you won't miss any future episodes. See you in the next one.